Good day, students. Welcome to mathgotserved.com. In this clip, we're going to be going over problems 35 to 37 of the Algebra 2 Common Core New York Regents exam for January 2017. Alright, let's take a look at question 35. It reads, the guidance department has reported that of the senior class, 2.3% are members of Key Club K, 8.6% are enrolled in AP Physics P, and 1.9% in both. Question. Determine the probability of P given K to the nearest tenth of a percent. Okay, so for this one, let's go ahead and write down the formula that helps us to determine the probability of an event occurring given another event. Okay, so let's take a look at the formula for a concept known as conditional probability. Okay, so the probability of an event A occurring given B is written with the notation P of A with the bar and then B. Okay, probability of A given B is the probability of A and B divided by the probability of B. Okay? Alright, so let's list the different scenarios that we're dealing with here, the different events that we're going to be calculating the probability of in this problem. We have P for the percent enrolled in physics. Okay? Enrolled in AP Physics. And then we have K for the members of Key Club. Okay, member of Key Club. So now let's go ahead and apply this probability formula to this particular problem. Okay, so the formula is applied. What are we going to have? We're going to have the probability of P given K, probability of being enrolled in AP Physics, given that a student is a member of Key Club, that's going to be equal to the probability of being enrolled in Physics P and being a member of Key Club K, that divided by the probability of being a member of Key Club K. Okay? Alright, so let's list what we know. So what do we know here? We need the numerator probability of P and K. What does this mean? Let's write it out. This is the probability of being enrolled in AP Physics and being a member of the Key Club. Okay, member of Key Club. And what is that probability based on what we're told in the problem? Members of AP Physics and the members of the Key Club and enrollment in AP Physics, 1.9%. Okay, 1.9% are in both. So probability of Key Club and AP Physics is going to be 1.9. How about the probability of being in a member of Key Club? Probability of being a member of Key Club is 2.3%. Okay, 2.3% are members of Key Club, so the probability of a student being a member of Key Club is 2.3%. So P of K, the meaning is the probability of being a member of Key Club. And the numerical percentage value of that is 2.3%. Okay? Now we're ready to solve the problem because we have everything that we need. So the probability of P given K is basically the probability of P and K divided by the probability of K. We already stated that earlier. So probability of P and K is going to be 1.9 divided by probability of K, which is 2.3. Alright, so let's go ahead and compute the quotient with our calculators. So we have 1.9 divided by 2.3, and that gives us 0.8261. So it's going to be 0.8261. Now, in percent, it's going to be 82.61%. We're asked to round to the, let's see, what we're asked to round to. Round to the nearest tenth of a percent. So this is going to be 82.6% to the nearest tenth of a percent. To the nearest tenth. Alright, so there goes the answer to the first part of question number 35. Alright, so let's take a look at the second part of question 35. It reads, the principal will like a basic interpretation of these results. Write a statement relating your calculated probabilities to student enrollment in the given situation. So basically, what does that 82.6% result we got in the previous part mean? We just want to write it in a sentence. So it basically means that a Key Club member has an 82.6% chance, probability of being what? Of being enrolled in AP Physics. So that's the meaning of the result that we got in the previous part. Alright, let's take a look at question 36. It reads, using the formula below, determine the monthly payment on a 5-year car loan with a monthly percentage of 0.0625 for a car with an original cost of $21,000 and a $1,000 down payment to the nearest cent. Okay, so before we solve this, something to keep in mind when you're buying a car, there's something called there's the original cost, there is the amount borrowed, and there is the down payment. Okay, so something to note, it's not clearly stated in this problem, is that the amount borrowed is not always the original cost of the car. Okay, if you have down payment, as is the case here, the amount borrowed is going to be the original cost minus the down payment. Okay. Alright, so let's go ahead and solve this problem. It asks for the, what does it ask us to find? Determine the monthly payment. Okay, so monthly payment, we have a question mark here. We don't know this. Okay. We have one equation. We can have only one unknown. So let's specify what these other values are. Plug it into the equation and solve for PMT, the monthly payment. Alright. So what is the amount borrowed? Amount borrowed is the cost minus down payment. We talked about that earlier. So the cost of the car is $21,000. Subtract the down payment of $1,000, and you have $20,000 as the amount borrowed. Number of monthly pay periods. We have 5 years. How many months are there in 5 years? We know that there are 12 months in a year. So for this particular problem, we are going to compute 5 times 12, which is 60 months. Interest rate is 0.625%. So you want to be careful when computing calculations using percentage, you have to convert it to decimal form. Okay, this is accomplished by moving the decimal point 2 places to the left, 1, 2, and then you put a 0 here, of course. So 0.625 is equivalent to 0.00625 in decimal form. Alright, let's go ahead and compute the car payment. So what do we have here? We have the car payment. So let's just rewrite the formula. So the formula is P sub n equals PMT times 1 minus 1 plus I to the negative n over I. Okay, so what we're going to do is plug in what we know and find what we need. P sub n is 20,000 equals PMT, which is unknown, times 1 minus 1 plus the interest of 0.00625 raised to the period, the number of months, negative 60. That divided by your interest, which is 0.00625. Okay? So let's go ahead and enter this entire expression into the calculator, convert it into decimal form, divide both sides by that value. That will isolate the monthly payment. Alright, so let's bring out our calculators, and we're going to compute the quotient here. So we have, let's see, we're going to separate the numerator and the denominator. Okay, so for the numerator we have parentheses 1 minus parentheses 1 plus 0.00625, close that, raised to the negative 60th power. Okay, close your numerator, divided by your denominator, which is 0.00625. Okay. Alright, hit enter. We get 49.9053. So 20,000 equals, let's write this properly. It's equal to 49.9053 times the payment times PMT. Alright, visualize this as an algebraic equation. This could be a variable x. Okay, how would you get the variable isolated? You divide by the coefficient, right? So you divide by this coefficient. In this case, the coefficient is 49.9053 on both sides. Okay, now if you carry out that division, that will help us find what the monthly payment is, which is, in our calculators, we'll enter 20,000 divided by the previous answer. So if I want to insert the previous answer, I can just divide by second function negative. We'll call up my previous answer, enter, and we have 400.76 to the nearest cent. So 400.76. That's the monthly payment. Okay, let's take a look at the B part for question 36. It says the affordable monthly payment is $300 for the same time period. Question: determine an appropriate down payment to the nearest dollar. Okay. All right. So these are the steps that we're going to follow to accomplish this goal right here. So let's write them down. Number one, you are going to find the total amount borrowed. You're going to find the total amount borrowed using the formula, okay? That's given. And then secondly, remember we are trying to find the down payment. So we're going to determine the down payment by doing what? We determine the down payment by finding the difference between the original cost and the amount borrowed. So determine the down payment by finding the original cost of the car, which is 21,000, minus the amount borrowed figure that you got from the first part. So amount borrowed from 1. Okay, so these are the steps we're going to use to solve the problem. Okay, all right, let's do the first part. First part is to find the amount borrowed. Okay, find amount borrowed, and that is p sub n. All right, so since p sub n is our unknown, we need to assign values to the other variables. PMT is the monthly payment. In this particular case is 300. The same length of time is 5 years times 12, which is 60. Interest rate is still unchanged, 0.625, which is equivalent to 0.00625 in decimal form. P sub n is the amount borrowed. That's what we're looking for. Okay? Alright, so let's recollect that formula, that long, complicated formula that we're going to use to find the amount borrowed. P sub n equals the monthly payment, PMT, times 1 minus 1 plus the interest raised to the period of time, negative period of time, over the interest. Okay, so let's do this. P sub n is going to be PMT, which is 300, times 1 minus 1 plus the interest rate in decimal form. All this raised to negative 60. And then we divide that by the interest rate, which is 0.00625. Okay. Alright, so all we do is input this expression into our calculators and compute the result. Okay, so let's go ahead and enter it. Make sure we do this carefully. So we have 300. Well, let's do the numerator. Well, yeah, 300 times. Now we're going to enter the fraction. Open the parentheses for the fraction, and then I'll open the parentheses for the numerator. Okay, so 1 minus parentheses 1 plus 0.00625. You can just do 1.00625 if you want. Close that, raise it to the negative 60th power. Not minus, this is negative, okay? So we go ahead and close the numerator, and then divide it by the denominator, which is 0.00625, and then close this entire expression. Enter, and that's what you get. So that's your amount borrowed. Okay. All right. So let's write that down. Amount borrowed, P sub n, is going to be 14,971.60 cents. Now we're going to proceed to the second part, which is to find the down payment. Okay, so let's find the down payment. So how do we find the down payment? The down payment, talked about this earlier, is basically the amount, the original cost minus the amount borrowed, right? So that's how we're going to find our down payment. The original cost of the car is $21,000. I'm going to subtract the amount borrowed, which is $14,971.60. Alright, let's bring back our calculators. So we're just going to do 21,000 minus the previous answer. And then we get 6,028 and 40 cents. To the nearest dollar is going to be $6,028 for your down payment. Okay? So that's that for this part of the problem. Okay, let's take a look at question number 37. It says the speed of a tidal wave s in hundreds of miles per hour can be modeled by the equation s equals root t minus 2t plus 6, where t represents the time from its origin in hours. Algebraically determine the time when s is equal to 0. Okay, so what are the steps for solving radical equations algebraically? Let's go ahead and write it down. Steps for solving radicals algebraically. It's very easy to do this with a calculator, but it's a different story when you're doing it by hand as required by this problem. So first things first, you want to isolate the radical term or terms. Isolate the radical term. In this particular problem, there's only one radical term, so we're just going to be isolating one radical term. Why are we isolating it? The goal is we want to eliminate it. Okay, so after you isolate it in step 1, step 2 is to eliminate the radical by squaring. Why do we square? We square because that is the inverse of the square root. Okay, so when you eliminate the radical by squaring, something interesting happens. Apart from eliminating the radical, there might be a possibility of introducing something called extraneous solutions. Okay, so step 3, you're going to solve the resulting equation, and your answers could be both correct. One could be correct or neither could be correct. So how do we determine which answers are actual solutions or which are extraneous? Step 4 is extremely important. You want to check for extraneous solutions. Solutions that do not satisfy the original equation but were introduced in the process of squaring in step 2. Okay, so that's very important. Alright, so let's go ahead and solve this radical equation right here. The original problem is s is equal to rad t minus 2t plus 6. We asked to find t when s is equal to 0. So when s is equal to 0, we have the following equation. Following radical equation, 0 equals the square root of t minus 2t plus 6. Okay? Now let's go ahead and do the steps. Step number 1 is to isolate the radical. So step 1 is isolate. How do we isolate the radical terms? We need to get rid of 2t and 6. So we use the inverse operations. You add 2t to both sides, and then you subtract 6. When you do that, we have 2t minus 6 is equal to rad t. Next step, step 2 is to eliminate. We want to eliminate the radical. How do we do that? Remember, we said you accomplish that by squaring. So we're going to square both sides of our equation. Okay, so we square the left, this entire quantity, and we square the right. Alright, when we square this, we have 2t minus 6 times 2t minus 6. And on the right side, the square and square roots are inverses, so they cancel each other out. And we are left with t. Okay, so we're going to go ahead and expand this out completely. Okay, since we're multiplying two binomials, we can just FOIL it out first, outer, inner, last. So just multiply the 2t to these two terms, and then you go ahead and distribute the -6 to these two terms here. Alright, let's do it. 2t times 2t is 4t squared. 2t times 6 is -12t. -6 times 2t is another -12t. -6 times -6 is +36 equals t. Okay? Now we have a quadratic equation. Let's go ahead and put it in standard form. And we can also combine like terms, okay? So if we combine like terms here, we're going to have 4t squared. Combine these two, minus 24t. Their signs are the same, so you add and keep the sign. Plus 36 equals t. And then we proceed to subtract t from both sides of the equation. So you subtract t and subtract t. And what does that give us? It yields the quadratic 4t squared minus 25t plus 36 equals 0. Alright, now we're advancing to part 3, which is to solve the resulting equation. Okay, so part 3, now we're going to solve. So how do we solve quadratic equations? Different methods. Let's try factoring first. If it's prime, then we will use the quadratic formula. Okay, so we're going to use the AC method here. Check to see if we can reduce this. 4 goes into 4 and 36. It doesn't go into 25, so it cannot be reduced. AC goes on top, B goes on the bottom. Okay, so in this problem, A is 4, B is -25, and C is 36. Okay, so AC is 4 times 36, which is 144. B is -25. Okay, so we're going to play the X game. Okay, so the X game is it requires finding two numbers that multiply to give you the top and add to give you the bottom. Now our AC is pretty big, so it's not going to be that easy to do this mentally, although some of you are really smart and you can do it with ease. You can exhaust the combinations, but I'm going to write it out so that we all can see exactly what is happening. Okay, so we're looking for a combination of numbers that multiply to yield 144 and whose sum is 25. Let's start from the beginning. 1 times 44 is 144. This combination gives 145 or 143. Nowhere near what we want. 2 goes into 144 since it's an even number, 72 times. This combination yields 74 or 70. No good. 3 definitely goes into 144 because if you add the digits, you get 9. That means 3 goes, right? 3 goes into 144 48 times. This combination yields 51 or 45. No good. 4 goes into 144 36 times. Just look at the last two digits. Since 4 goes into the last two, 4 goes into the entire number. This combination yields 40 or 32. No good. Moving along. 6. Since 2 and 3 go into 144, 6 certainly goes into it. 6 goes into 144 24 times. This combination yields the sum is 30. The difference is 18. That doesn't work. Moving along. 9. Does 9 go into 144? Certainly does, since 3 goes into 48. So 9 goes into 144 16 times. This gives us 25 and 7. 25 is exactly what we need, so we have the winning pair. Okay. If this didn't work, we just have to keep going. Okay, and then this one, the next combination will be 12 times 12, and we have a complete pair. We've exhausted all the pairs, so that will be the end. Had it been that none of these pairs work, that will mean that our problem is prime and we have to use the quadratic formula. But this problem, we have a situation where we have a pair that works, even though it took us a while to find it, but we have one. Both of them have to be negative in order for the sum to be negative and the product to be positive. Okay, so let's insert that here. So we're going to write this quadratic trinomial as a quadratic with 4 terms, and then we will proceed to factor by grouping. Okay. Alright, so let's divvy down the center right in front of this sign. From the first two, we'll pull out the GCF, which is t. So pull out t, and we have 4t minus 9. From the next two, we'll pull out the GCF, which is negative 4. And then we have 4t. Since you took out a minus, this plus switches to a negative. Now this is where you freeze and make sure that the quantities in the parentheses are identical. And that is the case here. So that means that we are on the right track. So we'll factor out the quantities that are identical, the 4t minus 9s. And we'll pull that out. We have 4t minus 9. And the term on the outside gets grouped together in their own nice little parentheses. T minus 4 equals 0. Alright, so now we'll proceed to set both factors to 0. And then we solve. Alright, so this one we add 9 and divide by 4. So we have 4t equals 9. Divide by 4. And then we have t equals 9 over 4. That's our first potential solution. Remember the possibility that there could be extraneous solutions, so we don't know for a certainty if this is a solution. Alright, solve this. Subtract 4 from both sides. You have t equals 4 as your second answer. So how do we know which is real and which is extraneous? Which one works and which doesn't? We have to test both of them. Okay, so we're going to test both of them in the equation, the original equation. I do not remember what it is. So we're going to test them in the equation rad t minus 2t plus 6 equals 0. Okay, so first one that we are going to test is 9 over 4. So when t is equal to 9 over 4, does it satisfy this equation? In other words, if I substitute 9 over 4 into this equation, do I get a true statement? Question is root 9 over 4 minus 2 times 9 over 4 plus 6, is it equal to 0? Is it? Let's simplify this. This becomes 3 over 2. When we multiply this, 2 goes here twice, so we have 9 over 2. Plus, we can write 6 as an equivalent fraction with a denominator of 2. This is accomplished by multiplying 2 to the top and bottom, so 12 over 2. Why did I do that? I want all my denominators to be identical because that is a requirement for combining fractions. You need a LCD. Okay, now since they're all identical, we now just evaluate the top. 3 minus 9 is negative 6. Negative 6 plus 12 is positive 6. Is 6 over 2 equals 0? Is 3 equals 0? The answer is no. So that tells us that this solution is extraneous. Alright, so does that mean that the other one is a solution? No, there are no guarantees. We have to test both because there's a possibility that this radical equation has no solutions at all. Okay, so we test this one by substituting into the original problem and asking ourselves, do we end up with a true statement? Square root of 4 is 2, minus 2 times 4 is 8, plus 6. Is this equal to 0? 2 minus 8 is negative 6 plus 6. That's 0. Is 0 equal to 0? Absolutely. So our solution for this radical equation is t equals 4. Okay? So that's that. All right, now let's take a look at the next part. It says, how much faster was the tidal wave after 1 hour than 3 hours to the nearest mile per hour? So in the original problem, let's take a look at it. The original problem is in hundreds of miles per hour. Okay? But in the problem that we're doing right now, it says miles per hour. So we're going to have to make an adjustment there. Okay, basically multiplying our answers by 100 since we're switching from miles per 100 miles per hour into just miles per hour. Okay, so that's something to keep in mind. Okay, so we just have to find how much more this is than this, so we're just going to subtract. Okay, so we need to go determine the speed at 1 hour. So that's basically going to be s of 1. So we just plug it into the function. The function s of t is root t minus 2t plus 6. So s of 1, you just plug 1 into the function, minus 2 times 1 plus 6, which is equal to square root of 1 is 1. 1 minus 2 plus 6. Final result is 5. And then the speed at 3 hours, evaluate the function at t equals 3. So we're going to have root 3 minus 2 times 3 plus 6. Okay, so root 3 cannot be reduced any further. Negative 6 plus 6, these cancel out to root 3. Okay, so how much more speed at 1 hour than 3 hours is basically the difference between s of 1 and s of 3. S of 1 is 5 minus s of 3, which is root 3. Okay, let's find out the decimal equivalent of this difference. We have 5 minus the square root of 3, which is 3.267. Okay, so no, 3.268. So it's 3.268 hundreds of miles per hour. So how about in miles per hour? Okay, so to find miles per hour, we multiply by 100. All right, so to find miles per hour, multiply by 100. Okay, so when we do that, we have 3.268 times 100. That just moves the decimal point 2 places to the right? So we have 326.8 miles per hour. 3.26 miles per hour. We're asked to round to the nearest miles per hour, so our final result will be 327 miles per hour to the nearest hour. Okay, so that's that. Thank you so much for taking the time to watch this presentation. We really appreciate it. If you found the contents of this tutorial helpful in your preparation for the upcoming Regents exam, do give us a thumbs up. Your positive feedback is very valuable to us. If you have any questions or comments about what we covered in this tutorial, just place it in the comment section below and we will be more than glad to support you. Don't forget to subscribe to our channel for updates to other cool math tutorials such as this. More clips can be found on mathgotserved.com. We have solutions there, formulas, tips, and tricks to help you succeed. Thanks again for watching and have a wonderful day. Goodbye.